This is question 7 from the third CSAT sample paper. If you see this 7 turn to an 8 in a second and me announce something else, that's just because this question was initially misnumbered. Don't panic, this is indeed going to be question 7. This is question 8 from the third CSAT sample paper. And in this question we're given some information about two sequences, AN and BN. And we know they start off with A0 equals B0. And then if we think of A and Bn as a vector, so the x-coordinate is An and the y-coordinate is Bn, then to get to A and Bn from An minus 1, Bn minus 1, we just multiply the vector by this matrix. And we're asked to find the simplest non-recursive form of Bn over An. So non-recursive means we're not relating this to previous values of B and A. It might depend on n, but it's not, for instance, it's not going to be something like 1 plus bn minus 1 over an minus 1. That would be recursive. Okay, so if you want to have a go at this question yourself, pause the video now. So first of all, they've given us this information about sequences in a convoluted way where we have to multiply by a matrix. So let's just unpack this. We know how to do matrix multiplication. So that means this will turn into a couple of equations, one for the x-coordinate and one for the y-coordinate, if we think of it that way. So first let's calculate what an is in terms of these things. How do we get this coordinate? Well, we do the top row of the matrix times the it would be the first column of a matrix, but just times by the vectors. That means we do 1 times this plus y times this. So 1 times an minus 1 is just an minus 1, and then we have plus y times bn minus 1. And I'll call this 1 so I can come back to it later, and we'll just look at the second coordinate now, or second component. And to get this one, we just do the bottom row of the matrix times this. So that means 0 times this plus 1 times this, and that just comes out as, well, 0 times this is 0, plus 1 times this is just plus bn minus 1. So we just get bn equals bn minus 1, and I'll call that 2. So this is simpler, and it only relates to b, it doesn't relate to both of them. So it makes sense to start with this and then come back to this when we have more information about b. So what does 2 tell us? It basically tells us that b is a constant sequence because each term is the same as the last one. So, okay, bn equals bn minus 1, but bn minus 1 is going to be equal to bn minus 2, and etc. all the way down to b0. So we know that all the terms in the sequence are just equal to b0, whatever that is. And this is going to be true for all n. So, okay, now let's go back to here. Well, one thing we can say about this is we now know what the value of this term is. We know that bn minus 1 is just the same as b0, so we can plug that in. And what we have to recognise about this is, okay, we've got an equals an minus 1 plus something, so to get to the next term we start with the previous term and add something, and this something is constant. It depends on y, which we're not told anything about, so it's just a constant number, and b0, which is just some constant number that's the first term in the sequence. So that means we've basically got an arithmetic progression because we're just adding a constant to get from one term to the next. This is the common difference. And that means, since that's constant, to get to an, we start with a0, and then we just add n lots of this. Because a1 would be a0 plus 1 lot of this, a2 would be plus another lot, so that's a0 plus 2 lots, etc. all the way down. So an is a0 plus n times y times b0. And now we've kind of run out of things to do, except that we were asked for the ratio bn over an, rather than bn and an separately. So let's see what that ratio looks like. Well, the first thing to note is we kind of want stuff to cancel. We don't really want anything depending on a and b as far as possible. So what we note here is we're told at the beginning that a0 is b0, so we can take b0 out as a common factor. And then remember, if we're doing bn divided by an, it's useful to remember that bn is just the same as b0, so that's going to be common. And when we do the ratio, that means we have b naught over this, which is b naught times something, so we can just cancel those factors. And we just get 1 over 1 plus ny. And this is non-recursive because it doesn't depend on a or b. And there's no way to simplify this because we aren't told anything about y. So this is our final answer.